Hello, my name is Melanie Dove, and thank you for attending my presentation at the SAS Global Forum 2021. I'm an assistant professor at the University of California, Davis in the Department of Public Health Sciences, and I also teach an Introduction to SAS class for graduate students. My colleague on this presentation is Catherine Heck, and she is a researcher for the Center for Health Equity at UC San Francisco. And she is also the data manager and lead analyst for a survey called the California Maternal and Infant Health Assessment Survey. And today we'll be talking to you about survey data analysis made easy with SAS. This is an outline of our talk. We'll describe why we need to use survey procedures, some key survey design features, and we'll describe 4 examples with SAS code. We'll talk about PROC survey freak, survey means, survey logistic, and survey reg. So what is a survey? It's a sample of individuals that represent a population. As shown in this illustration, we have in the large circle, we have the target population. And from the target population, we are selecting 4 individuals to be in our sample or our survey. Some examples of surveys are the National Health and Nutrition Examination Survey or the National Health Interview Survey. So why do we need to use survey procedures to analyze our data? We need to take into account the design of the survey. This includes the sampling and the weighting. And first we'll talk about the sampling. And sampling does not mean getting free food at Costco. There's different ways that we can sample a survey. One way is simple random sampling. Here we have an illustration where we have our target population, and we randomly select 3 individuals to be in our sample. Another way that we could sample the population is using stratified sampling. Here we have our target population, and we divide our population first into groups based on shades of gray. And then from each group, we randomly sample from each group to be in our survey. And this ensures that we have enough people from each group in our sample. So this illustration shows the difference between stratified sampling and cluster sampling. So the panel on the left shows stratified sampling, where we have our target population, and each circle represents a person. And we divide our population into groups, in this case, based on color. And we sample from each group in stratified sampling. In cluster-based sampling, we also divide our population into groups. But instead of sampling from each group, we select the whole group to be in our sample. In this case, we're selecting these 2 groups to be in our sample. So when we adjust for the sampling design in our SAS code, we need to take into account the fact that individuals within the same cluster or the same strata are more similar to each other than individuals from a different cluster or strata. And if we don't take this into account, we'll overestimate the variance and thus the significance of our findings. We'll be more likely to find significant results than if we didn't take this into account. So the other design feature that we need to take into account in our SAS code is weighting. And weighting does not mean, these dumbbells that, make your arms stronger. A weight is a value indicating the number of people each respondent represents. So here we have our illustration again of our target population and our 4-person sample. And if we apply this illustration to the California Health Interview Survey, we see that there are about 24,000 people in the CHIS sample. And each person is assigned a set of weights so that when we analyze the data, our estimates are representative of the target population, which has almost 4 million people. The weighting corrects for differing probability of sampling in different clusters or strata. It also corrects for non-response. And so people who respond to the survey there's certain characteristics of people that respond to the survey that are different than people that don't respond to the survey. And we can take this into account through the weights. So now we'll talk about a few key survey design features. One is the strata statement, which adjusts for stratification. Another is the cluster statement, which adjusts for clustering. And then we have a weight statement, which adjusts for the weighting. One of the key survey design features is when we conduct subpopulation analysis, we want to use the domain statement or flag variables to look at certain populations. We don't want to subset the data using a where, by, or if statement. For example, if we just want to look at women, we would use the domain statement or flag variables to just look at women. We wouldn't create a new data set that just contains women. And this is because when SAS estimates the variance, it takes into account the survey design features. And in order to do this, it needs to look at the whole population. So before we get into some examples using some SAS examples, we'll describe two surveys that we'll be using in those examples. These are the National Health and Nutrition Examination Survey, or NHANES, and the California Health Interview Survey, or CHIS. So NHANES is uses a stratified and a cluster design. It's an in-person, and there's one weight per person. So this is an example, an illustration of the NHANES sampling procedures. And so in stage 1, PSUs or counties are selected. And this is an example of cluster sampling. The entire PSU or county is selected. And then within counties, segments of the population are selected, and then households, and then finally individuals are selected into the survey. So CHIS uses a very different design. It is a stratified random sample. It's a telephone-based survey, and it uses replicate weights, where it assigns 80 weights per person. So here's an illustration of the CHIS survey. The target population is California, and California is grouped into different areas by geography. And within each geographic group, telephone numbers are selected, and then these numbers are called, and individuals within households are selected. So now we'll get into the SAS code. So this is the general syntax for the PROC survey freak procedure. So we have, we use the statement PROC survey freak, we specify our data set, and then we specify the variance method. And in this case, we're specifying the Taylor variance method, which is the default. And then next we have our strata, cluster, and weight statements, where we specify the variables for each of these factors. And then we have our table statement, where we specify our categorical variable, and then finally a run statement. So here's the SAS code. if we were to analyze non-survey data. So this is the Proc Survey Freak SAS code applied to the NHANES data set. So we have our Proc Survey Freak example, our statement, we specify our data set NHANES, and NHANES uses the Taylor method for to estimate the variance, which is the default, so we don't need to list it on the first line. We specify our strata statement, our cluster statement, our cluster variable, and then our weight variable. And then here we're asking for the frequency of the variable RID-RET3, which is race ethnicity. And then we use a / and then CL to ask for the confidence limits. Again, here is the equivalent code for non-survey data. So here we have a chart looking at the results, first without survey procedures and then with survey procedures. And we can see that the sample size for each category is the same in both cases. However, the percents and the 95% confidence intervals are different. If we look at the first row, we see if we don't use survey procedures, we estimate 17% of our sample is Mexican American. With survey procedures, this estimate is 11.1%. And this is because NHANES slightly overestimates Mexican Americans in its sample, so that if we just look at the sample, we get a larger percentage of Mexican Americans. However, if we want to estimate the percentage in the United States, it's closer to 11.1. And if we look at the 95% confidence intervals, we see that they're much narrower without survey procedures compared with survey procedures. And this is because when we take into account the survey design elements, it adjusts for the fact that individuals within the same cluster or strata are more similar. And so the 95% confidence intervals are a little bit wider. Okay, next we'll look at the Proc Survey Freak procedure applied to the CHIS example. And in this case, we're asking the question, does hypertension differ by gender? And so we have our Proc Survey Freak statement. We specify our data set is CHIS. And CHIS uses the jackknife method to estimate the variance. And so we specify that here. And then CHIS also uses replicate weights. And so we have a base weight that we specify with the weight statement. And then we use the rep weight statement to list our 80 replicate weights. And then we have a table statement where we're doing a crosstab of the variable for gender times hypertension. And then we're asking for the row percent, the confidence limits again. We're saying we don't want any totals, and we're asking for the chi-square. So here are our results. And we can see that among males, 31% have hypertension, and among females, 25.8% have hypertension. And if we look at the chi-square statistic, the p-value from the chi-square statistic, it's less than 0.05, indicating that there is an association between gender and hypertension. It looks like men have a slightly higher percentage of hypertension compared with women. So as a reminder, we don't want to subset the data. So in this case, to get the percentage of men and women with hypertension, we used a crosstab. We don't want to create a new data set of only women to get the percent of hypertension among women. Similarly, we don't want to use a where or an if statement in our PROC Survey Freak code to just look at women. And this is because SAS uses the entire sample to get information about all the survey design features in order to estimate the variance. Okay, so that was the PROC Survey Freak procedure. Now we'll move on to PROC Survey Means, and we'll use the CHIS example. And we'll ask the question, does the frequency of walking for leisure differ by age? And so here we have our PROC Survey Means statement. We specify our data set and the variance method. And again, we have our weight and our rep weight statement. And so for most of the SAS codes, the first part will be similar. So for PROC Survey Freak and PROC Survey Means, the variance method, the weight variable and the rep weight variable, this part of the code was similar. And so once we get this part down, it's fairly straightforward to do PROC Survey Freak or PROC Survey Means. Then we have our var statement where we specify our continuous variable. In this case, it's how often you walk for leisure in the past week. And then we have our domain statement, which is our categorical grouping variable. And in this case, it's age, and then a run statement. So here are our results. And we can see that in the youngest age group, 18 to 29, there's a mean of 3.0 compared to the oldest age group with a mean of 2.5. And so it looks like the younger age group walks a little bit more than the older age group. Okay, so next we'll look at the PROC Survey logistic for code, also using the CHIS example. And we'll ask the question, are you more likely to not have a usual source of care if you are uninsured? And so here we use PROC Survey logistic. We specify our data set and the variance method. Again, we have the same weight and rep weight statement as we did with PROC Freak and PROC Survey Means. We have our class statement where we list our categorical variables, including the option to specify that the referent category is uninsured. And then we have our model statement where we list our outcome of no usual source of care equals our predictor of uninsured. And we also have a format statement. Here are the results from our logistic regression analysis. And over here, we have our odds ratio estimates. And we can see that if you are uninsured, you are about 5.2 times as likely to not have a usual source of care compared to if you are insured. Okay, our last SAS example is linear regression, which uses the PROC Survey Reg procedure. And for this example, we will be using the NHANES data set. And we'll ask the question, does cotinine differ by health insurance status? So cotinine is a continuous variable, and cotinine is a metabolite of nicotine. So here we have our PROC Survey Reg SAS statement. We specify our data set, and the variance method is the Taylor, which is the default. So we don't need to specify it on the first line. We specify our strata variable, our cluster variable, and our weight variable. Just as a reminder, in NHANES, there's just one weight per person. And here we introduce the domain statement. So on our domain statement, we have a variable called set that equals 1 if you're in our data, in our analysis population, and 0 otherwise. For example, if we're looking at cotinine, we may want to restrict our analysis to just adults who are non-smokers. So in this case, set would equal 1 if you're an adult and you're a non-smoker, and 0 otherwise. And then we have our class statement where we list our categorical variable of health insurance. And then our model statement where we list our continuous predictor, cotinine, equals our categorical, our continuous outcome equals our categorical predictor. We include the option of solution to request the parameter estimates and CLPARM to request the confidence limits. Here are our results, and we see at the top, we see that these are the results for set equals 1, and there'll be a separate set of results for set equals 0. And doing it this way, SAS, using the domain statement, SAS still uses the entire population of data to estimate the variance. Okay, and then here we see our regression coefficients. We see that if you have Medicaid for insurance, you have higher cotinine levels compared to being uninsured. And if you have private health insurance, you have lower cotinine levels compared to being uninsured. So today we talked about, what a survey is. It's a sample of the population, and there's different ways to sample the population. You could do a simple random sample, a stratified sample, a cluster-based sample. And we need to adjust for these design features in SAS. And we do that using the survey features in SAS. And we looked at examples using the CHIS data and the NHANES data. And we looked at the PROC survey free, PROC survey means, survey logistic, and survey reg procedure. So thank you so much for listening to our presentation. And please contact us if you have any questions. Thank you.